Hello everybody, we're going to be starting our 10.4 notes today, area of circles and sectors. So our objectives are students will be able to find the area of circles and sectors and able to find the area of shaded regions. So first, the area of a circle is A equals pi r squared, where A is just the area, pi is pi, right, pi, and that is a button we can find on our calculator. Originally we might have learned it as 3.14. There might be times where we're going to leave it as pi. There's going to be other times where we want to find a decimal answer, and we were just going to use the calculator for that. We're just going to use the pi symbol. We don't have to worry about using 3.14. And then r, of course, is the radius. So r is the radius. Right, and then it is also important that if we know the diameter, in order to find the radius, it's 2 times the radius, so therefore we want to take 1/2 of the diameter for the radius. Alright, so find the area for each circle shown below. Write your answer in terms of pi. So since we're writing it in terms of pi, we're leaving pi in our answer. So the area equals pi r, which is 14, squared. So we just take 14 and square that, which is 196. So the area is 196 pi, and then meters squared. I want to include that measurement there. All right, number 2. So area equals pi r squared. This is the diameter, so this whole thing is the diameter. So in order to find the radius, I only need 1/2 of that, so therefore it's going to be 6. So I'm going to have pi times 6 squared, so 6 squared is 36, so I'm going to have 36 pi inches squared. So when it wants it in pi, we just leave the pi right next to the number. 3, a circle has an area of 49 pi inches squared. Find the length of the radius and the diameter of the circle. So remember, area equals pi r squared. It tells us what the area is, so that's going to be plugged in to my a value. So I now have 49 pi equals pi r squared. And so there's a couple ways to look at this. One, you might say, okay, well, the pi's are in common, so what squared will give me 49? That is a valid way to find what your r is, but let's go through all the inverse operation steps. So I'm going to first start with dividing out pi. So even though it is a super long decimal, it's sort of like if I say x divided by x. I don't know quite what x is, but I can do that and they will cancel out. Same thing with my pi's. So I can cancel out my pi. And I now have 49 equals r squared. Then I can go ahead and take the square root, and I'm going to have r equals 7. So my radius is 7 inches. It also wants us to find the diameter. So remember, the diameter is 2 times the radius. So I'm going to take the diameter is 2 times 7. So my diameter is 14 inches. Alright, go ahead and try number 4. It's very similar to number 3, so go ahead and give that a shot. Pause the video. When you unpause it, it should be back. Alright, and here's number 4. We have our radius and our diameter. Alright, let's go ahead. I want you guys to pause the video again because we have an exploration. It's not through GeoGebra, you just need to answer these questions. So we will go through it together, but go ahead and try them out on your own first. Alright, hopefully I had a chance to pause the video and try it. Let's go ahead and try it together. So first we want to find, Amy is buying a rug with a radius of 4 feet as shown. What is the area of the rug? So area, it is a circle. So we're going to have pi r squared. The radius is 4, so we're going to have pi times 4 squared, which is going to be 16 pi. And it's feet, so we can put feet squared. All right. It doesn't tell us to do decimals or pi, but I'm just going to go ahead and leave it as pi. All right, B, Amy finds another rug with the same radius, but that is exactly half of a circle, so called a semicircle. What is the area of this rug? So since we have essentially the same circle, if I were to continue drawing the circle, right? Sorry for my poor circle drawing skills. But if you were to continue drawing that circle, you would have our original circle. So all we need to do is take the area and divide it by 2. So we already know what the area of the entire circle is, which is 16 pi. So if we divide that by 2, I'm going to end up with 8 pi, and then feet squared. And then C, Amy now finds a rug with the same radius, but it is only a quarter of a circle. What is the area of this rug? So once again, we know a quarter. So remember, a quarter, that's 4 pieces. If I were to continue, I would have 1 here, 2 here, and 3 here. Sorry, that's an awful circle. Doesn't even look like a circle. There we go. So we have 4 pieces to this circle. So therefore, if I were to take the original circle and divide it by 4, I would have the area of each one of these pieces. So therefore, it would give me 1/4, 1/4 of my circle. So let's go ahead and take 16 pi and divide it by 4. So the area of the quarter of the circle will be 4 pi feet squared. Alright, and what this is called a sector. So a sector of a circle is a pie-shaped slice of a circle. It is between 2 radii and an arc of a circle. So if we take a look here, this definitely looks like a piece of pie. If you're like, well, that divided by 4, I don't really typically cut a pie like that, but it is a slice of a pie, right? If we just think about circle and we think about pie. And it's a good way to remember that we are using pi with circle as well. But we have 2 radii on either side, and then we have the arc, and then that inside part is the sector. So the area of a sector can be found by finding a fraction of the area of a circle. So A equals m divided by 360 times area of circle. So A equals m over 360 times pi r squared. So m is the measure of the arc. So measure of arc. Right, because we're a part of the circle, a fraction of that circle. So we want to find the area of each sector to the nearest tenth. So since we're finding a decimal, then we are going to plug it into a calculator with the pi symbol. So let's go ahead and start. We have A equals m, so area of the sector. So we have to remember that the central angle is congruent to the arc, so 100 degrees divided by 360 times pi r, which is 7 centimeters squared. Alright, so we can go ahead and simplify, which would give me 5 over 18 times 49 pi, or also you can just plug this whole thing straight into a calculator. You can also do that, especially since we are going to have to find it to the nearest tenth. We aren't just leaving it as a fraction, or we're not leaving it with pi. Since we're not doing that, we can go ahead and take it, plug it into a calculator, and find our final answer. Alright, so I'm going to go ahead and plug it into the calculator from here. I'm going to do 5 divided by 18 times 49 pi. If you need help with plugging that into a calculator, remember anything in the denominator is division, and anything in the numerator is multiplication. Remember, that is all over 1. We multiply straight across. So I actually have 5 times 49 pi all over 18. So you can plug it in like that. Plug in the numerator, put parentheses around it, and divide it all by 18. And you could have done that as well with this original problem that we had up here. Alright, but once we plug that into a calculator, the area of the sector is going to be 42.8 8 centimeters squared. Alright, let's go ahead and try that again with number 5. So number 5, we have the area, we have 80 all over 360 times pi r squared. So we have the radius here, that's our r, and this is our m, the measure of the arc. Alright, let's go ahead and just plug this into a calculator, right? Since we're trying to find the nearest tenth, we might as well make it a little bit easier on ourselves. So 80 times, I am going to write 16 though, because 4 squared is 16. Sometimes with larger numbers, if you like, you know, maybe you have 20 and you're like, I'm not quite sure what that is, you can leave it as 20 squared. And then all over 360. Alright, so let's go ahead and plug this into a calculator. Alright, so we have area equals 11.2 feet squared. Alright, let's go ahead and have you guys try 6 and 7. So we are finding just the shaded region, so the sector of the circle. So then pause the video, try those two out. Alright, and there is 6 and 7. So I set up the equation, I did the square, and then I set up the fraction that we would plug into our calculator to get our answer. Alright, let's check out 7, 8, and 9. So we want to find the area of the shaded sector to the nearest tenth. So let's go ahead and start with number 7. So this time we still want the shaded region, but as you can see, the arc length that we know is not the shaded region. We have to remember that the entire circle is 360 degrees. So if I take 360 and subtract 120, I'm going to end up with 240. So what this tells me is that this whole arc here is 240 degrees, and then I can plug that into my equation. So I have 240 all over 360 times pi and then 9 squared. Let's go ahead and simplify that and make one large fraction so that we have something to just plug straight into the calculator, because we are rounding to the nearest tenth, so we don't need to leave it as a fraction or a pi. Alright, and so when I plug this into a calculator, I get 169.6. That's the area. Alright, so go ahead and you try number 8. Very similar to what we just did here. We want to find what this measure is. Alright, and there's number 8. Now, let's go ahead and check out number 9. So a sector has a measure of 60 degrees and a radius of 9. Find the area of the sector as an exact answer in terms of pi. So since we want to figure out an exact answer, we're going to go ahead and leave things in terms of pi, where we really don't need to use our calculator too much. We want to simplify our fractions. We can use the calculator, but we definitely don't need to use the calculator, depending on what you need for your fraction, of course. Sorry, that's what I meant. We don't need it for like the pi and finding a decimal answer for our final answer. Alright, so we have a circle. Let's go ahead and draw a picture. Since we don't have one, that's a good place to start. If you do not have a picture, always draw one. Even if it isn't exact. I know that we have 60 degrees here. The radius is 9. And we want to find the area of the sector as an exact answer in terms of pi. So we have our picture set up, so let's go ahead and plug everything in. So I have 60 all over 360 times pi 9 squared. So I'm going to go ahead and start simplifying this fraction. So since they both have zeros, I know that can cancel out. And then 6 does go into 36. We do have to recognize that it isn't 36 divided by 6, that it is 6 divided by 36. So my answer is not going to be just 6. My answer is going to be 1 over 6, right? So 6 goes into 6 once, 6 goes into 36 6 times. So I now have 1 over 6 pi and then 81. So remember, this is multiplication straight across. So I do have 81 divided by 6. I am going to leave the pi out. So you can kind of think of it as a variable. you know, if I had 2x or 1/2 x, we kind of just put that x right off to the side because we're not really doing anything with it at this moment. So same thing with pi. We're not doing anything with it at this moment. So 81/6, I can simplify that because 3 goes into both of these. So 3 goes into 81 27 times, and 3 goes into 6 twice. So whenever we're finding an exact answer, it's best to leave it as a fraction. But since this does give us an exact decimal, so it's not like, you know how 1/3 is 0.333, right, repeating. 27/2, that is not a repeating decimal, so technically it is still an exact answer if you decided to give that decimal answer. But you do have to be cautious of that. If you have a bunch of decimals, that is not an exact answer. If you have 1 or 2 that you can show all of the decimals, then it is an exact answer. So for this one, I'm going to have 13.5 pi. So either one of those will work. Alright, let's go ahead and take a look at 10 and 11. So give an exact answer in terms of pi, find the area of the shaded region. So we have this circle, right? And it does give us the diameter, even though it looks like we have the diagonal of a rectangle, which we do, but it does give us the diameter because it goes from one end of the circle to the other end, and it goes through the center. So we do have the diameter, but I've taken out this rectangle on the inside of my circle. So if I find the area of the circle, subtract the area of the rectangle, then I'm going to have the rest of the circle around it. So let's go ahead and start with the circle. So circle, remember, is pi r squared. I know the diameter, or well, I can find the diameter, right? Because we have a right triangle here. So we have 8 and 6. I recognize that I can divide both of those by 2, which would be 4 and 3, which is a, not special right triangle, a Pythagorean triple. There we go. So to multiply by 10, the diameter, or multiply by 2 to get the diameter of 10. Sorry, mixing up my numbers. So if the diameter is 10, diameter equals 10. If we go ahead and divide that by 2, it will give me my radius. So my radius equals 5 squared pi. Remember, this does want exact answers, so I'm leaving it in terms of pi. So my circle is 25 pi. So I figured out my circle. Let's go ahead and figure out the area of my rectangle. So the area of the rectangle is length times width. So I can say 8 times 6. We don't need the diagonal for the rectangle, we only needed it for the circle. So we have 8 times 6, which will give me 48. So in order to find the area of just the shaded region, I'm going to take the circle, so 25 pi, and I'm going to subtract the part I don't know, which is 48. Since it wants it in terms of pi, I cannot simplify this any further because 48 doesn't have a pi, so I can't combine these two numbers. So remember, pi, you can think of it very similar to a variable. It's like I said, 25x minus 48, we can't combine that. So this is my exact answer, and that is the shaded region. Even though it still looks like a statement and we have more to do, that is the exact answer. Alright, for number 11, it's going to be very similar. So this time we have a circle inside of a square instead of another shape inside the circle. So we are going to have to find the area of both regions. Let's go ahead and start with the circle again. So remember, circle is pi r squared. You might be thinking, well, there's nothing inside my circle. Since this is a square and the circle goes from end to end, the square is the same length all the way around, so this has to be 10. So the diameter of my circle is 10, and we actually just did that, right? So I know that my radius is 5. So pi, 5 squared, so 25 pi is my circle. Alright, let's go ahead and find the square. So the square is length times width, or side squared, whichever way you want to think about it. So 10 squared equals 100. Alright, so if we want to find the area, and this time we're finding parts of the square, so that means I want to take the square and subtract the circle out of it. So 100 minus 25 pi. And that is the exact answer. Once again, we can't combine it. So to decide which one you're subtracting from which, take the whole that you're starting with. So with number 10, I'm starting with the circle and I took out a rectangle. Number 11, I started with a square and I took out a circle. So whatever you're taking out, whatever the shape that's not highlighted in the center, that's what you're subtracting out. Alright, and that is the end of 10.4. If you have any questions, be sure to ask. Rewatch as needed, and have a wonderful rest of your day.